everyone. Thanks for tuning in to today's presentation. It's called A Legacy of Net Zero Buildings. I'd like to introduce myself. I'm Eddie Dearden of GNAR Inc., the co-founder and director here. We are a sustainable building design. Oh, I think I've got a, I didn't. We're a sustainable building design company, self-described, and we're passionate about the environment and addressing the climate emergency through sustainable building design and construction. And so that led to the theme for today's meeting, which is about the legacy of net zero buildings that will be left behind. And I came up with this quote that I liked. It is up to us to live up to the legacy that was left to us, and to leave a legacy that is worthy of our children and future generations. For myself, my views of what legacy mean are sort of shaped a lot by my poppy, which is Australian for grandfather. He inherited the farm that I grew up on when he was 16 years old. And he was still working and living on the land when he passed away at 89 years old, leaving 5 children and 12 grandchildren. So when I think of legacy, I think of what I might be doing when I'm 89 years old, which will be the year 2074. And we're currently in the year 2021. And so this is what I'm seeing. I am seeing that net zero targets have been legislated at every level of government in the country of Canada. And in fact, Canada is a signatory to a legally binding international treaty. So I heard this quote last week that I thought fit perfectly by the hockey player Wayne Gretzky. Some call him the greatest athlete who ever lived. He played over 20 professional seasons in the pro league, and he once said, "I never skate to where the puck is. I skate to where the puck will be." So as far as I can tell, the puck is going to net zero, and anything less is kind of in 20th century building versus a 21st century building. What is net zero? So the true definition and what we're really trying to achieve here is net zero emissions. So that's a balance of when a human-caused carbon dioxide emission or equivalent emissions of other greenhouse gases are balanced by the removals of those gases.
So I will work it out. I think
someone mute. Okay, there we go. So that means unless there's technology that gets verified that can certifiably remove carbon from the atmosphere in a permanent long-term basis, no fossil carbon can be added to the atmosphere. And really, in this presentation, I'm talking a lot about these 2050 targets that governments have signed up to. But if you're up to date with what the scientists are really asking for, they would prefer that we hit these net zero targets within the next decade if we can. So this graph sort of shows the optimum path for us to net zero. This comes from the latest Intergovernmental Panel on Climate Change report, which was released 2 months ago. This latest report is a significant upgrade from the last report that was released in 2018. There was still a lot of uncertainty in 2018, but the science is rapidly evolving, and at this point, there's absolutely no doubt that this is fact. And in fact, the Intergovernmental Panel on Climate Change, it means every government in the world, 196 of them, have a seat at this panel, and they can all fling whatever doubt and alternate opinions and facts at this. And the scientists at this point have disproven every single counter theory so I'm not going to really get into the science, but as far as I'm concerned, this is fact at this point, having read the latest report. I do, these lines, these show carbon dioxide emissions over time. As a skier, I've got my own interpretation of this in terms of sort of the impact on powder. So this lowest line that takes us to net zero by 2050, I consider that the powder still possible line. This next one that gets us to 2.6 degrees of warming, the UN released a report just this week showing that we're on path to 2.7 degrees of warming. So we are definitely on this line at best. That's the way less powder line. It's a lot better than some of these other lines, which are sort of more like no civilization line, or, way up here, 8.5 degrees of, I mean, we don't really need to contemplate this. This is, no one's talking about that, but, we're really deciding which of these three lines, and still the orange line is quite unpleasant in the future. So, currently what's going on is the climate conference, which starts in 2 days. It's a conference of parties, so every single one of those 196 countries will get together and maybe decide on some new legislation. So, this presentation may even be slightly out of date within the next 2 weeks, but certainly the most recent and significant international progress on climate change was achieved in 2015, when the governments of the world agreed that we were going to target to limit warming on the planet to 1.5 degrees and absolutely not go over 2 degrees, which, as I mentioned, we are currently on track for 2.7 degrees of warming. So we're not hitting that. Here's a picture I found with the various presidents and world leaders. Actually, I didn't see where Trudeau is in this, but basically all the leaders of the world are on board with this. And so that's led to the various national level net zero targets. My home country of Australia also just adopted a net zero target, although with questionable policies supporting it. But certainly in Canada, this was adopted. Actually, it was only adopted in June of this year, so it's quite recent. Maybe not everyone is aware of it, but basically what it says is that it's formalizing our ambition to achieve net zero emissions by the year 2050. And we're going to get there by setting a series of intermediate 5-year targets with the government ratcheting up action as we go. And when this legislation was passed, I remember in the news, it was very big on the 2035 target, when no fossil fuel powered vehicles will be allowed to be sold in the country of Canada. But in the building sector, we have to realize that that same target basically equals to us in our own context of buildings. British Columbia has, as a essentially a global leader, has had the British Columbia Climate Change Accountability Act since 2007. Whether that's achieved its goals, I don't think it has necessarily. The current NDP government has just proposed new amendments, and again, it's a process of ratcheting up. So even if some of the previous legislation hasn't achieved its goals, well, we all see what's happening with the natural disasters and the heat domes and flooding and so forth. So presumably over time, some government at some point will get very serious about this stuff. On a municipal level, this has been translated into policies such as the Whistler RMOW's Big Move strategy. These are all across municipalities in British Columbia. I think Nelson has a very ambitious municipal level target, and they're doing something like every year they're renovating 180 houses to net zero in Nelson. And of course, well, Vancouver is, they've had their Greenest City 2020 goal for quite a while. So in respect to buildings, as we see here, is the Big Moves 4 and Big Moves 5. Big Move 4, it says that Whistler will achieve the highest level of the BC Energy Step Code prior to 2030. And I was just informed the other day that they're planning to bring in Step 5 within the next 12 months. So that's good. But the much more challenging Big Move 5 says that they will target to reduce emissions from existing buildings by 40% by 2030. So they really have to get moving on that. And so that policy, they said, will come out around January, February, which will be their new green building guide. which I understand is quite comprehensive. So they think they're going to have some sort of methodology to achieve 40% reduction in emissions. I'll wait to see the details on that one, but obviously that involves all of you, builders, designers, architects, engineers, have to get in. This is a lot about emissions. So emissions from buildings in British Columbia are mostly caused by the use of fossil gas, which gets burnt and releases carbon dioxide to the atmosphere, and also the extraction and transportation of methane gas in the province is potentially a much greater contributor to climate change in the short term. So basically this big move strategy, and at the last council meeting, I asked Mayor and Council a question about this, and they said on the public record that their goal is to remove natural gas from all buildings in Whistler. So probably shouldn't be putting it into new buildings. So how's this, talking about the policies? Obviously, we're all familiar with the BC Energy Step Code, which was introduced in the 2018 BC Building Code. And that says that by 2032, all new buildings in British Columbia will achieve the Step 5, which is otherwise known as net zero ready. So from energy efficiency standpoint, the building is energy efficient enough that you could put solar panels on the roof and generate the energy for that building. So the key point is buildings built today, obviously in various municipalities, we're allowed to build at lower step codes, but this is very highly unusual. Certainly the building code development department doesn't usually tell you what the guardrail code will be in 10 years. And if they did, certainly I would hope some people would be inclined to build guardrails to the future code rather than what you're allowed to. And so, we know that every building in the province will be built to net zero within the next decade. So buildings that are not built to net zero today, if we see where the puck is going, at some point, every house on the street will be net zero. So the ones that are not net zero will presumably be sold at a lower value. And then the flip side is we all know that construction costs rise over time. So it will never be as cheap to build net zero as it is today. So just when we're selling to our clients, obviously it's the imperative on lots of projects to save on money. But as we will see in one of the upcoming case studies, it certainly costs far more and is far more complex to retrofit a building to net zero than it is to build one to net zero in the first instance. And then how do we ensure the consistent quality and labeling and standards of net zero? Well, that's where the Canadian Home Builders Association is really leading the pack here and has set up a national home energy labeling program, both for new buildings and for energy retrofits. And GNAR was lucky enough in collaboration with RDC Fine Homes to have the first net zero labeled energy retrofit, which was at Gates Lake, just north of Pemberton. So, in that case, fortunately, the building was built in the 1970s and was completely out of date and very due for an energy retrofit. So, a lot of the costs could be justified in just the general renovation upkeep that was required for the building. But yeah, certainly, the builder has communicated to me that did come at a cost premium. It was not cheap to achieve that. So more broadly, there's around 13 million homes that were in Canada in 2018 and projected to be 14.6 million by 2023. So that really leads to statements. I'm not sure who this quote was attributed to, but 80% of all the net zero buildings of the future have already been built. Please don't build any new buildings that need retrofits. As mentioned, they are very complex, and it's much more justifiable to be retrofitting buildings built in the 70s, 80s, and 90s than buildings built, when we already know what the future standard are. So how are we going to get to this point where we have net zero buildings across the country? Well, Fortunately, organizations such as the Pembina organization and other not-for-profits have been looking into the problem, and they've calculated that in order to achieve the 2050 net zero targets that have been set at every level, we will need to retrofit 4 to 5% of buildings per year, every year. They've understand that that's not happening currently. So in their modeling, they allow for a ramp up between 2021 and 2025. By 2025, they assume we're achieving 4 to 5% of energy retrofits every year thereafter until 2050. So talking about the emissions side of it, and as I mentioned, obviously the burning of the substance commonly known as natural gas, which I prefer to call fossil gas, as it's a fossil fuel gas, and natural I feel is a little misleading of a name. Certainly, some people say natural gas because it comes from the ground. I would counter that with, well, radon also comes from the ground and isn't known as natural gas, but it's being phased out all over the world. In 42 cities in the United States, including San Francisco and Stanford, natural or fossil gas has been banned, in various ways. Every different municipality has their different policy. The states of Washington and California are looking at implementing it at a state level. The United Kingdom has banned any new fossil gas installations from the year 2025, as has much of Europe. And Vancouver has, in their updated zoning amendments, banned any new fossil gas installations starting January 1st, 2022. And again, they have these broad plans for fuel switching that will happen thereafter. So a lot of work going on in Vancouver. I think they've got an inventory. They know roughly how many fossil gas heating systems there are, and they have some sort of strategy they've been working on to how to get all of those out of the buildings. Other people say that, I've certainly had conversations along a lot of these topics about the energy retrofits, and the feedback. A lot of people do their devil's advocate thing and say, well, I don't really believe that's going to happen. And certainly I don't necessarily know what the policies are, but we can see to the future in Europe. The European Commission has passed into law the European Green Deal, which promises to revamp the EU economy. So they're looking at this as a positive economic driver, slash carbon pollution. And what it involves is a mandate that all member states renovate 3% of their building stock to net zero emissions every year, which is around 35 million by 2030. So this has been passed by the European Commission at this point, which is the highest level in the EU. So as I understand their process, this has now been passed to the member states to develop their national level policies about how they're going to implement it. And of course, Europe is a very old country. In Czech, for example, there's buildings that are over 1,100 years old. So, certainly if we think we have challenges getting to net zero, there will be countries in the EU that face very unique and novel problems of how to implement these policies. The World Green Building Council puts it very simply in a new report that also, like many, was released this year. And that says that every building on the planet must be net zero carbon by 2050 to keep global warming below 2 degrees Celsius. And again, as I noted, we're not even on that path at this point. They say this will require a monumental and coordinated effort by business, governments, and non-governmental organizations to bring the building sector in line with the Paris Agreement goals. We need nothing short of dramatic and ambitious transformation from a world of thousands of net zero buildings to 1 billion net zero buildings if we are to avoid the worst impacts of climate change. So right now, a simple way of thinking about this, especially in BC, where we have an abundant supply of low emission hydroelectricity, is electrify everything. So anything that uses fossil fuel energy sources will just have to be removed. And whether that happens today with some generous rebates, a house which has a fossil gas furnace in it is, and I confirmed this with Better Homes BC, they could potentially achieve between $20,000 and $25,000 of rebate for a sort of 3,000 square foot house with a fossil gas furnace. If they just did the whole meal deal whopper energy retrofit, there should be, and Better Homes BC told me I'm allowed to say this, $25,000-ish, certainly at least $20,000 of retrofit rebates available for that. So net zero for sale, are we seeing any premium for net zero homes? I didn't actually get sufficient research on this to know the answer, but I definitely am seeing this Passive House Australia posting about this. They feel it in Australia with the heat that net zero buildings are very attractive there because they're very comfortable. My brother is messaging me at the moment. He says his house is horrible. He pays hundreds of dollars a month for air conditioning. So, certainly, and I think in following from the heat dome that hit the province of British Columbia this summer, I've heard a lot of feedback from people, such as I know at least 3 people in different buildings who had to move out of their home for 1 week and live in an air-conditioned hotel because their homes were unlivable. And then I know a couple of people that live in the Orion building, which is a case study coming up, and they reported that they were perfectly comfortable through the heat dome and they didn't even have high energy bills. So, I think we can see that net zero is going to, super insulated buildings and buildings which abide by passive house principles, so they don't overheat, but they don't get cold in the summer, are certainly going to be a desirable thing in the future. And absolutely, once retrofit mandates come in, if and when that happens, well, who wants to buy a home with it and get stuck with the headache of having to commit to one of these expensive renovation projects, when they'd much prefer to spend the money on a nice kitchen or something. This is just my personal opinion. I'm trying to see where the puck is going. I've got a young daughter, and the heat dome was very scary, keeping her cool. So, a lot of devil's advocate type people say, I don't think step 3 houses built in 2021 will be subject to retrofits. I feel a bit differently. I don't see people of the future who start to experience annual heat waves similar to the one we've just experienced, cutting any slack for people who decided to save a few bucks in 2021. I do believe that some of this stuff is quite serious, and the political will just grow with time. But that's just my personal opinion, and I know a lot of people don't agree with that. So what is at stake? Well, in recent years, we've experienced multiple heartbreaking tragedies, such as the fires that ripped through the town of Paradise in California on the left, and more recently Lytton here on the right. So this is a huge risk to us, either from wildfires or heat waves or flooding or hailstorms. Yeah, who knows? And the flip side, as I mentioned, super insulated buildings are really a great mitigation tool. Against things like the heat dome. Oh, another example, actually just here in my office, which I've documented on numerous occasions, that my office building is horribly insulated, has thermal bridges throughout. It's a tilt-up concrete building, which really shouldn't be allowed in this climate without some outsolation. And during the heat dome, it was impossible for me to work in my office. The air conditioning just couldn't keep up. It was very uncomfortable. And just in the hallway the other day, one of the other tenants here was explaining that their air conditioning broke down during the heat dome and they had to shut their business for a week. So, this is causing all sorts of headaches, from, keeping our children safe to disruption of business service and so forth. So, and people having to move out of their home to just to survive. But net zero, it's really coming. I know that there's several builders in Whistler who are really committed to this. Innovation Building Group and RDC Fine Homes, who worked with us on the two projects upcoming, have shown a real commitment to net zero and getting their clients on board and delivering that not only with new builds but also with renovations. A builder in the North Vancouver area who I was talking with, Kingdom Builders, they say that they will not take on any project that is not equal to step 5 or passive. So, you know, certainly some builders are stepping up and achieving that. And, you know, if you go look for net zero case studies and retrofit case studies, there's just so many of them. In researching for this, I must have found at least 50 case studies of net zero, and a lot of them are really saying that this can be done cost effectively and efficiently and provides great payback. So this is one such. This is one project that we were not involved on. If you go on ecohome.net, this is the case study on the front page of their website, which is a pilot project of actually 35 net zero energy ready homes built in Montreal, Quebec. So similar to here, I think that's a zone 6 climate. And so they did a lot of study on these. So I'm so sorry, it's cut off like the total energy consumption and, okay. How can I see that? Okay, well, actually what this shows, and just to summarize the findings of the study that they did, is basically one of these homes without the solar panels, I think they had to pay $800 a year was their annual energy spend. And the homes that had the solar panels and an EV charger, including charging an EV, were able to operate at dead zero. That these homes cost zero energy cost annualized to operate in a zone 6 climate. And they were building these for, I think, around $250 a square foot. So certainly this is a verified study, and it is possible if you set out to achieve net zero right from the early design and concept stages of a project, then make sure that you pay good attention to things like orientation, making use of the solar resources available. I do believe that this sort of building can be achieved cost effectively, and certainly when we get the right type of client who doesn't insist on some unnecessary amenity in their home, then those clients, it is very easily achievable with people who have views to the north, for example. I know that's much more challenging, and we've seen the flip side as well. We just went with the client and put a bunch of windows on the north side, and when we get to the energy model, we find it's actually impossible for us to hit step 5 with this house. It's just got too much north-facing glazing. But yeah, so certainly it's not like something that you can just slap step 5 or net zero on any house, but if you start from this beginning, you can achieve it affordably, I truly believe. So the Orion building in Pemberton, this is by Innovation Building Group, potentially, and feel free to correct me, but a recent study, well, this building has been very studied. It's been 3 different organizations, including BCIT and ZEBEX, have done studies on this building. And essentially, as far as I can tell, it is the most energy efficient building in Canada. The entire building uses 8 kilowatts per meter squared per annum for heating and cooling of the living space. And I think costs in the order of a couple of $100 for each of the units per year. I know several residents of this building who were the ones which reported that they were perfectly comfortable through the heat dome. So I am kind of jealous. My home is horrible and uncomfortable, as I mentioned, and we had to shelter with all the blinds closed and we couldn't turn on lights in our house. If we turned on lights, it would instantly overheat inside our house. So it was a very unpleasant experience for myself. But fortunately, we have got a contract with Innovation Building Group, and this project in Sechelt, the government of Sechelt is amazing. We've got this project from our initial rezoning proposal. It's got its final reading before it achieves rezoning in this month, and hopefully we'll be building the successor to Orion with a goal to achieve an even higher energy efficiency. yeah, so if anyone's interested, I can actually email you 3 different case studies for this building. But the conclusion was, because they studied 6 buildings in British Columbia, and that's where they potentially say this is the most efficient building in Canada, because several of the other buildings were contenders for that. You know, that wasn't really what the study set out to conclude. It was just investigating the cost, the construction cost. And this whole building was built for less than $250 per square foot. And it and one other all-electric building were constructed for considerably less than other buildings in the study, which were built to code minimum. So the study concluded that high-performance all-electric buildings can be constructed for less than the average cost of similar code minimum buildings. Then I get on to our Gates Lake project, done in collaboration with RDC Fine Homes and with Capital Home Energy, were the energy advisor and who achieved the net zero label. So I'm a little less familiar with the actual labeling process, but certainly GNAR came in. This building had no existing drawings. We had to site measure everything from scratch and figure out how we were going to insulate it. And with the 3D BIM software, we were able to slice and dice this project in every which way. And RDC, were a really great partner. They really a lot of collaborative work to figure out all the different insulation strategies, such as insulating in the attic, insulating in the joist space, and adding extra insulation where there was no, not enough space in the cavity. We had to get into the crawl space and so forth. Like I mentioned, the builder wanted me to express that this did not come cheaply, but certainly if you look at the before and after pictures, you'll see that this building has been completely revitalized from sort of a rather beat up and very uncomfortable cabin to a modern net zero beautiful, yeah, just beautiful. There was an interior designer, also BM Designs. So we all know what a renovation can achieve, and it can give new life to a building. And despite the cost premium of bringing these buildings up to net zero, there is simply no better time to do so than when renovating a home. So I think we really need to see every time we renovate a building as an opportunity to pitch to the homeowners, either fuel switching or upgrading the insulation or the mechanical systems, whatever you can get. There's 100 little choices, and each one of them costs money, and whether the homeowners have the financial resources to achieve that is certainly, some of them just don't, and then others, I think, well, actually moving on to, I'll jump ahead because it's on the same topic. So deep energy retrofits, there's lots of options, such as fuel switching, so taking out fossil fuel energy systems. It's pretty cheap up front, but unfortunately, the economics of the situation are that electricity costs more than fossil gas. So there's this horrible economic driver that are leading many homeowners to go with a more environmentally destructive option. So fuel switching is, but that's really one of the most important things that we can do to reduce the impacts of climate change. Certainly, fossil gas it's a double-edged sword, in fact, because what people call natural gas, it is made up primarily of methane. It's 90 to 95% methane, and methane is itself a powerful greenhouse gas, much worse than carbon dioxide. So when the methane itself escapes to the atmosphere, it causes a lot of short-term warming. Okay, so that's the fuel switching, and then the other side is the deep energy retrofit, such as what we did on the Gates Lake project. And here we have another house in Whistler. This was a super janky house. It had 17 different roof pitches, and we were able to combine a renovation with an addition to take most of the corners out of this house. At the end of the project, it only had 4 roof slopes and mostly 4 walls, except for this little L at the front of the building. And so that made for super easy insulation details. The homeowner added a lot of outsulation and we're hoping for a really great air tightness test once this is complete. So really, those are two options, and then everything in between. So a full passive house energy retrofit obviously is going to cost a lot of money, but will provide a lot of future value, especially if there's some sort of energy label that says this house is not going to be in line for a future energy retrofit. But anything that you can get your clients to commit to, then that's absolutely great in my book. But option A should always be, if you're building a new home today and we know where that puck is going, it should be built to a net zero standard, regardless of what the local municipality requires. Because if you're not building to that standard, well, it's just a house that, excuse me for saying so, it will be kind of redundant in under 10 years. And we all know buildings are supposed to last for much longer than that, preferably 40, preferably. I'd love to know that the legacy of buildings that we design lasts for 100 years or more. So thoughts on that. But then there's the other side, is the carrot versus the stick. Well, as I mentioned, currently there's some quite generous rebates available to improve the energy efficiency of existing homes. I mean, hopefully those persist. Hopefully the government will continue supporting this sector of the economy, but we never really know. Maybe at some point the government won't have the financial resources it has right now, for example. But then on the flip side of it, I just read in my research for this presentation that Vancouver already has plans to fine buildings exceeding maximum allowable emissions limits as soon as 2030. So as we know, a lot of stuff that starts in Vancouver finds its way into the rest of the province. And so again, this is just another tool that we can use when talking to our clients about the necessity to get the fossil gas or other fossil fuel sources out of their homes. Is if you're in your house and you're renovating, do it now and save yourself the headache of having to re-renovate your home in the future. So what are the first steps? Well, if you're not already building net zero or passive house, I mean, I can highly recommend the passive house course for literally anyone in the construction sector. Here at GNAR, we have every single one of our staff has done the passive house course, including our two interior designers. And it just, the passive house principles, there's so much there that you can do, achieve, just putting the windows on the south side of the building. And I really mean that, having been passionately working on energy efficient buildings for close to a decade now, you really see even putting windows on the east and west is significantly less beneficial than having them within 10 degrees of south. So that's just a principle that you can use. And if you do that and you put it into the energy model, you're going to find that your house achieves a step 5 or passive house much easier than, I've seen houses, there's I mean, unfortunately, a place like Cadenwood has a view to the north. I saw a couple of houses in Wedgwoods where they also have a view to the north, and whoever the designer architect was on those houses have put all the glazing on the north where the view is, and those houses will never achieve step 5. So either someone will retrospectively go and replace those windows with walls, or who knows what will happen in the future. But if you understand the passive house principles, you can avoid a lot of those pitfalls. But lots of other great programs around. I know the Canadian Home Builders Association offers a lot. A lot of building science courses. There's things like the Living Building Challenge, Zero Energy Certification. Whatever suits your particular business or interest even. I just absolutely recommend education. It's one of the core principles here at GNAR. The government of British Columbia costs 80% of the cost of eligible training, such as passive house. If you send any of your staff to do the passive house training, you only pay 20% of the cost. I mean, come on, it's like $200 to get someone to do this 128 passive house course. And I absolutely think every architect, engineer, and builder in the province should take just this one course, this single 4-day course, or I think 8 half days it's offered in also. And keep it simple. So, you know, again, if you can keep the geometry simple and observe the passive house principles, that's really the key to how you build net zero for cheaper than the other guy is building code minimum houses. You know, the second energy retrofit house I showed there, I was talking with the homeowner, and you know, obviously he's complaining as all homeowners do about the cost of construction, and I was just pointed out to him, just imagine if you tried to add all that outsolation to your original janky house with 17 exterior walls and 17 roof pitches, it would have cost way more. So yeah, he did agree that he's now got mostly 4 walls on his building, and they just covered them with outsolation, covered them with siding, and you know, it's been super easy project to deal with as the designer on it. The cost savings, you know, never forget this. And, you know, again, guys that are out there doing renovation projects, I was just talking with a builder up in Pemberton the other day, and he mentioned that there's a whole bunch of these small little super unpleasant, super poorly insulated condos, and those homeowners are paying $450 every 2 months to heat their homes with just electric baseboards. So I quickly, while I was on the phone with him, I plugged in some numbers. You know, say you save them $166 per month. If you allow for a 4% rate of return and 4% inflation on energy costs, that's $250,000. Those homeowners, and they're very small apartments. I imagine, you know, for 250 grand, you could achieve $166 a month energy saving. But then the flip side again. We see right now in the UK and Europe, and I think even here, fossil gas prices have doubled. I think they've more than tripled in Europe. So you know, it might seem like a cheap fuel source today, but you know, fracking, the process which most of the gas is extracted these days, has been banned across large areas of the European Union. And you know, as those extraction bans continue, the supply might be in shorter and shorter, or carbon taxes, who knows? But there's no guarantee that energy will be as cheap today as it is in the future as it is today. So just another tool. All right, well, that pretty much wraps up my presentation. Here's a little explainer. I didn't really talk about our company, GNAR Inc. As I mentioned, sustainable building design. So we do new custom homes and renovations. I mostly wanted to put these here because, you know, what we felt necessary to do is we've got a certified energy advisor in-house. We've got a certified passive house designer in-house. And so, you know, I know our experience prior to having the certified energy advisor on staff is it did cost us or the homeowner a lot of money to get the feedback on the energy models. And, you know, we are finding that doing all of our own energy modeling in-house, we were able to learn more and more and more, and draw on the growing library of energy reports that we've got to know what works and what doesn't work. And you know, we say sustainable interior design. We do training every day. Every morning we do a reading, and usually, you know, almost always on sustainability, but other topics such as history are welcome. And what we've seen is that our interior design staff, you know, the more that they learn about how fossil gas is such a potent greenhouse gas, and you know, contributing to the loss of snowpack at our local resort, our interior designers are key in that, because they, you know, often they're the ones that can talk a homeowner out of getting a gas fireplace or, you know, some other unsustainable element in their home. So, you know, it's not just the architects, it's not just the builder, interior designers, who knows? Engineers also, I think it's critical for them to be taking the passive house course or something similar, so they understand, don't put steel that goes through the envelope, you know, don't build all those thermal bridges, and get them on board with collaborating on how to deliver these buildings. So yeah, I think that's pretty much it. I hope you enjoyed the presentation. If anyone has any questions, I'd love to hear.
Hey there, Adam from RDC Fine Homes here. Could you just touch on the difference between net zero and net zero carbon?
Yeah, absolutely. Yeah, I didn't really get into that. So the net zero targets that are being legislated at all the levels of government are primarily net zero carbon. So carbon is emitted whenever we burn fossil fuels. So, natural gas, fossil gas, when you combust that releases carbon dioxide into the atmosphere, and that carbon has come from underneath the earth. Gas was formed that was organic matter that was sequestered from above the surface of the earth and ended up underneath the crust 100 million years ago. And we're taking huge volumes of that carbon out from under the earth and burning it and releasing it in the form of carbon dioxide to the atmosphere. Net zero emissions also refers to things like methane itself, which is a very potent greenhouse gas over a short lifespan. And so, even when you use gas, the extraction and transportation processes leak lots of fugitive emissions, and potentially that actually is a much more significant contributor. So the real most pressing planetary goal is net zero carbon or carbon dioxide equivalent emissions of greenhouse gases, as opposed to net zero energy in a total energy balance sense, which is also very important. And I'm still not sure which side of the fence. I do feel it's very important, obviously, to achieve that. But if you can just achieve the fuel switching and achieve the net zero carbon, that's a much more pressing concern. Some of the longer term concerns with the net zero energy. So if you do fuel switching and your home remains a bit of an energy hog, but it doesn't emit carbon, I mean, that's good in the short term, but as more and more of those buildings add up, it puts more of a stress on the energy grid. There was research from the Passive House Institute of Australia that showed that peak cooling demand in a hot climate can be devastating for the grid. And so, you can only have so many energy hogs sucking power at once. Otherwise, your energy grid needs to be super overdeveloped to handle those peaks, which will only get worse with time. And, another even longer term is the goal is to achieve net zero carbon, but all of the scenarios in which humanity survives the climate emergence assume a period of negative emissions. So, if we leave too many energy inefficient houses around, they're just consuming energy that needs to be devoted to the very serious future undertaking of removing massive amounts of carbon dioxide from the atmosphere. So, definitely getting to net zero emissions, priority number one, and achieving net zero energy balance or close to would be a close second.
Great, thanks very much.
Hey Eddie, Jake here. I was just gonna, sorry, we got two things open. I was gonna touch on the Gates Lake project there that we worked on together. I do feel that even though the client definitely paid a premium for that project to do a net zero renovation, we took a 50-year-old house that was basically on its last leg. We've made it's going to last at least another 50 years. Whereas if we'd just done a facelift, right, we would have probably, maybe extended its life by 20 years or so. So that high upfront cost does have long-term gains. And just another thing I think worth touching on is just the material selection and, natural materials, specifically wood, and some of these newer materials like hemp insulation, cellulose, all sequester carbon as well, and that helps give you a negative embodied energy build. So you're actually A, reducing your operating energy, and then B, reducing your overall embodied energy. So there's a double win there.
Oh yeah, that's awesome. Yeah, and I didn't really touch on that either, but there's everything about emissions which applies to the energy consumption of the house can be applied to the materials. Wood is sort of carbon neutral-ish. Other good materials, cellulose and hemp. I've no experience with the hemp products actually, but I understand they're quite good. But you just have to understand their application and maybe do some training. I was interesting. I did watch some YouTube recently on the manufacturing of plywood, and if you really look into how much energy is required to create plywood, it's definitely not carbon neutral. Like, despite the fact it's wood and it's made up of carbon, you emit more carbon than the plywood itself sequesters. So dimensional lumber is definitely a better sequesterer than engineered lumber. And then you get into, you know, if you're at that level, then you need to start looking at, well, how much more dimensional lumber then do you need than engineered wood, and so forth. But you know, as with the building emission standards that are coming, embodied carbon calculations will certainly be, that's in the future plan for the building code. So by 2030, presumably, all building permit applications will require the applicant to submit a report showing what their carbon emissions are of the building. And interestingly, in a conversation I had with another builder recently, you know, he was pointing out that when you do your prefab panelization projects, just how many trucks that saves going to the site. So, you know, there's a lot of dimensions to things that we can do to reduce climate change. So, you know, what I've said here is by no means definitive on everything. There's a lot of nuances and subtleties, and you know, I'm constantly, when I have these types of conversations, I'm sure each and every one of you would point out a dozen things like that I haven't thought of.
Eddie, there's just a question in the chat. I don't know if you can see it.
Okay, so what is the cost comparison to build a net zero to a standard step 3 or 4 house of the same size? Yeah, so absolutely, like it's almost like a misleading question, because like the simplest example that I can possibly think to explain this, to answer this question, is just imagine the simplest box, 4 walls and just windows on one side of the house. Now, if you build that box and just like a single roof pitch, a shed roof, this is the simplest possible house that you can build. If you point those windows to the south and have the right overhang, that house almost does not need any heat. You know, you can basically build that house without a heating system, or maybe like a teeny tiny wood stove, and boom, you've built an off-grid, net zero, super comfortable house that's going to have light all the time. And what I see, and what is, I hope one day we train enough builders and architects that this doesn't happen. There's a house across the road from Needle Lake Lodge, which is just one of those standard, they've got the windows facing to the view to the north. I see these massive glass windows that never have sun hit them, so they never get any of that beautiful free energy from the sun. And I just think to myself, like, my experiences of the things that homeowners say to me in the early conceptual design phases, and they say things like, I want lots of light. So, you know, whoever the designer of that building was probably like, oh yeah, they want lots of light, let's put huge windows. But they don't understand that if those windows were south facing, they could be much smaller and they would bring much more light into the house. So, you know, what is the cost comparison? A well-planned net zero house could be like significantly cheaper than a poorly conceived step 3 house. You know, a house with all the glazing to the north you know, you can plug that into an energy model, and you can design geometrically a house that it is impossible to achieve step 5. Like, no amount of insulation. You could have 3-foot big walls, but if you've got enough glazing on the north side of the building, you know, like passive house walls are R40. Passive house glass even is what, like R4 or 5 or something. So if you have enough R5 on the wrong side of the house, bleeding energy all through the 7-8 cold months of winter, it's not going to be possible to build a step 5, to get that to step 5, even with, you know, R100 walls. It's done. So, I mean, I see that you're from the district of Squamish, Richard, who asked that question. So I just feel, you know, the way I'm feeling these days is I feel that building departments really should, and in fact, the city of North Vancouver and the district of West Vancouver have already done this. They have retained passive house consultants to help review building applications. And so they are straight up, they've hired someone much more qualified than myself even in passive house, who gives feedback to all of the applications. And, you know, like, that's just such a freebie. If the building department would just receive this application and say like, hang on, you got a fossil gas system in here and you've got all your windows on the wrong side. Like, are you sure? Do you want to think about that? Yeah, like, why not? Like, that's it. In the community charter, it says that municipalities are allowed to inform and incentivize, and I do not see much information coming out of the building department on this. It's like, it doesn't, I'm not sure why building departments need to be completely passive. For sure, you know, if it's a fully engineered, fully everything design, it's going to be very disruptive and upset people if you come in and make this suggestion at that point. But every application goes through the building department, so you know, why not get involved and just, you know, somehow guide people who may not have taken this training or may not know any of the information in this presentation, and just, you know, say, here's a quick fact sheet or something.
Eddie, did you see Richard's response? He just wrote in the chat.
Yeah, feel free to reach out following this, Richard. I'm fortunate. Our company is designing. We've designed buildings in 13 different municipalities in British Columbia. I mean, there's 160 municipalities in total, so got a long way to go. But I've engaged with lots of different building departments by this point, and so yeah, that in itself, I hope building departments come together and share these ideas, and you know. I express that to the city of North Vancouver. They really got to reach out with what they're doing. It's very innovative, and they need to spread that far and wide. Any other questions? Okay, thanks, Richard. I got your email. I will reach out for sure. Okay, I didn't even put my email address on here. It's just info@gnarinc.com. So if anyone does want to reach out, just Google GNAR Inc. I think we're one of a kind. So yeah, I'm very happy to reach out and keep having these discussions with anyone out there. Other architects included. I love nothing better than to discuss this stuff with a good old architect. Also, just GNAR Inc. Our company, we specialize in BIM services, and we have partnered with quite a number. I think 6 registered architects now, where we've done the 3D BIM. And you know, it's a whole other, much more in the weeds of Passive House. But what we do, which is different, is we take the architecture and we take the structural and we put them together. So we model every single structural element on every project, kind of like what a prefab company does. But we do it on every project, even site framed. And when we put them together, we can find all the thermal bridges and really, really enhance the sustainability of the design through that, BIM coordination. So. Yeah, I mean, we're really interested in collaborating. We'll work with anyone who's interested in sustainable building design.
Well, Eddie, thank you very much. I thought that was very interesting. And again, if anyone wants to reach out, I can connect you with Eddie, or he's on our member list. And if you have any other questions, please send them our way. And yeah, if there's any other thoughts.
Some more chat. Okay. All right, well, thanks for attending, everyone. Really appreciate it.